What's going on, everybody? Today we're going to be doing another LeetCode problem. This one's called diameter of binary tree. So we're given the root of a binary tree. They want us to return the length of the diameter of the tree. And when they say diameter, they basically mean just the longest path between any two nodes in a tree, summing up the edges. So like if we look at this example here, we can see that the output is going to be 3 because that diameter, or the longest path between any two nodes on the trees, is going to be, we can see that between this 4, 2, 1, and 3, there are 3 edges, or E5, 2, 1, and 3. There's 3 edges in that path, so that's the longest diameter. So really, something that helps me understand this problem is kind of a trick for finding that max path. Is the idea here is we're gonna basically take the sum of the depths between the left and right child nodes of this tree recursively to find the max diameter. So just to kind of illustrate that a little bit, we can see that the depth of this left subtree recursively is going to be 2, right? Because you can either go this way or this way, but you definitely have to go this way, and you would get a max depth of 2. Going this way, you get a depth of 1. Summing those, you get a diameter, D for diameter, of 3, right? And these and this 2 and this 1 aren't really diameters, right? Those are just they're kind of like sub diameters, but really they're depths. So yeah, so let's get into the way I'm going to implement this recursively. So let's step through that like we were as if we were just stepping through the code. So we're going to start here at this 1, and we're going to start searching for the first thing we're going to do is try to find the maximum depths. So we're going to recursively call this function, and the function, our recursive function, is going to return depths. We're going to use a reference to a variable d to find our diameter. So there's kind of 2 variables we're updating here. One for the depth, which is what our recursive function is going to return, and then we'll just have a reference to the maximum overall diameter. So for our first basically recursive call, we're going to go down to this left child, and we're basically going to keep doing that until we find a null pointer. So we have a null pointer here, so we're going to return 0 once we find a null pointer, and then we're going to basically pop back up. But at that point, the next line of code is going to recursively call to search the right children. So we would next go down to this right child here. We would find a null pointer that would return 0, and then we're going to pop back up to this 4. Okay, so at this point, we want to calculate our diameter so far. And the way we're going to do that is it's going to either be the maximum value between whatever the diameter is currently. By the way, at first, this is just going to be 0 because our root node could be null. Or even if it was non-null, there's no edges there, so we can just assume a minimum diameter of 0 to begin with. So that's going to be 0, and it's either going to be that, or it's going to be the sum of the left and right depths, which right now are 0. So whatever's greater, it's obviously just going to remain as 0, right? Because the sum of these 2 depths, right? We just have null pointers here, so those edges don't count. It's going to remain as 0. So we'll say So our diameter is 0, and then we're actually going to return, once we return from a non-null node, we want to add 1 to our return value. So this return value here is going to be a 1. Okay, so then we can pop back up to our 2. And at this point, we need to keep searching for the depth at right children, so we'd go this way, but there's a left child here, so we would head that way first. And we reach a null pointer, so we return 0, and then we can pop back up to this 5. Now we're going to search this right child. Again, there's a null pointer there, so our return value would be 0, and then we pop back up to the 5. So now at this point we can calculate our, try to update our diameter, our max diameter. So we're going to sum these two values. It's going to give us 0, and obviously that's the same as 0, so our max diameter is going to stay as 0. So we're going to add 1 to the maximum of these two, right? Because we're updating our max depth now, really, in our return value. So that's going to be 1. Okay, so now we're going to pop back up to our 2. And at this point, we want to try to update the max depth again. So the sum of the max diameter again, sorry. So that's going to be the sum of these two, right? Which is 2. And that is greater than 0. So our new maximum diameter is going to be 2. And we can see that that is really just kind of like the sum of these two edges, right? It's like kind of what we just did. So, all right, so max depth or max diameter is 2 now. At this point, we also want to, we're going to have to return a value here, right? It's going to be the max depth so far. We need to add 1 to whatever the max depth was of those two children. So it's going to be 2. Okay, so now we can pop back up to this 1. And at this point, we're going to want to start searching the right children. So we would go down this way. We see a left node here, so we go this way. And then finally, we see that this node is null. So we return a 0. We pop back up, and then we're going to search to the right. We see a null pointer, so we return a 0, and we're going to pop back up again. And at this point, we can try and update our maximum diameter at this node. So it's going to be 0 plus 0 is just 0. That's not greater than this 2 here. So we're not going to update our max diameter, but we are going to update our max depth at this node. So it's going to be the max of these plus 1. So we will get a 1 here. All right, now we can pop back up to our 1. And at this point, we're going to try to update our max diameter. So we add the max depth of these two child nodes. So 2 plus 1 is going to be 3. That is greater than this 2. So we can update that maximum diameter to 3. And then at this point, we're going to want to take the max of these two to update that max depth. So it's going to be 2, and then we add 1. And we get 3 there. And that's basically the completed step through of the code, except I forgot to highlight the edges that comprise this max diameter. So that would have been, for sure, these two edges, and then it could have either been this one or this one, but we counted them both here. So yeah, so max diameter, there's 3. In terms of the time and space complexity for this, the time complexity is going to be big O of n, because we're going to have to visit every single node, including the null pointer children. So either way, it's going to be linear with respect to the total number of nodes in the tree for the time complexity. And then this space, we do have space in our recursive call stack, but it's pretty much going to grow with respect to the height h of the tree. So that will be our space complexity, because you notice as we traverse downwards in the tree, we're basically doing a depth first search, and thus the space complexity is going to scale with the height of the tree for that recursive call stack. So let's get into the code. So there isn't too much code to write here. We need a variable for our maximum diameter, so that'll just be 0 at first. We also need a separate recursive function, so I'll just call that find max d. That's going to have a return value of the maximum depth, and we're gonna keep track of the maximum diameter by reference. So so we'll be updating this variable here by reference. So we want to pass in the root node at first, so it'll take a node, and it will also take that max diameter variable by reference. So we can return max diameter once we're done doing all of that recursion, but we need to implement this function. So let's do that. So I'll make it a private function. It'll have an integer return value for that maximum depth, and then it's going to have a tree node, a pointer to a tree node. I'll just call that tn, and then also a reference integer to that max diameter, and I'll call it diam, because we're also going to have a depth variable, so I don't want to shorten that to d, because that could get confusing. So basically, the first thing we want to do is check, if we're at that null pointer node. So, and I called that variable tree node. So if tree node is null, then we can just return 0. We can return that depth of 0. And then at this point, we want to basically recursively call this function on the left and right children. So while keeping track of their depths, so our depth left is going to be whatever this function returns for the left child, and then we'll pass in that diameter, and then we want to do the same for the right child next, just like I whiteboarded. So do left first and then right. Okay, now at this point, we can try and update our maximum depth variable. So that's going to be our maximum diameter, sorry. So to do that, we'll just take the max of the diameter currently, and then the sum of the depth of the left child and right child. So okay, and then at the end of this, we can just return the actual depth of those children. So so that's going to be just the maximum between the left depth and the right depth plus 1. So that's pretty much it for the code. At this point, we can just submit this and make sure there's no bugs. But hopefully this video helped you understand the problem better. If it did, leave a like and subscribe, and I'll see you guys in the next piece.